fire single particles at two slits and tally where they land, and you get interference. Ripples of possibility stamped on a screen. Add a witch path detector that can even in principle record the route, and the interference fades. Remove the information and the ripples return. The stakes are plain. Outcomes seem to finalize when interactions create records that can propagate. Reality economizes. It doesn't lock every detail everywhere. It locks just enough where it matters. Push further with delayed choice. Decide after the particle has cleared the slits whether to preserve or erase path information, and the statistics line up with the later choice. No, effects don't travel backward in time. The math says that once all the relevant interactions are counted, sources, slits, detectors, memory channels, the record is consistent. What our instruments reveal is a habit. Amplitudes evolve broadly. Facts congeal where they can stick. Now the analogy, clearly marked as analogy, a VR engine does foveated rendering. It tracks your gaze and spends pixels in the center of vision, skimping on the periphery. Asset streaming pulls geometry into memory just ahead of you and unloads what's behind. Real-time ray tracing samples the light paths that matter and estimates the rest. The system cheats brilliantly to conserve resources, while your experience stays seamless. Quantum mechanics cheats differently. It evolves probability amplitudes until entanglement with an environment. For example, a detector, a grain of dust, your retina turns possibilities into stable records. Different domains, same logic. Don't pay for detail until consequence demands it. Here's where students' heads tilt. The observer isn't you. Consciousness isn't required. Any interaction that effectively entangles a system with many degrees of freedom, scattered photons, warm molecules, a noisy electrode, kills interference between alternatives in practice. That's decoherence. It explains why a macroscopic pointer lands on a number and stays there. Your mind shows up late to read the dial, not to set it. But there's one problem baked into lazy phrasing. Saying, measurement causes collapse invites a fuzzy question. What counts as measurement? Modern accounts swap slogans for mechanisms. The Schrödinger equation pushes amplitudes forward unitarily. Coupling to an environment spreads phase information uncontrollably across zillions of degrees of freedom. From the perspective of local observers who can't reverse that spread, alternatives stop interfering. Whether you prefer Copenhagen stories, many worlds branching, objective collapses, or pilot waves, the lab facts match. Interference where isolation and coherence survive, definite records where they don't, caution flag. The rendering metaphor explains nothing about the mechanism of measurement. It's a bridge for intuition across domains that share a cost function. In engines, the currency is GPU time and memory bandwidth. In physics, it's not compute cycles. It's the structure of interactions, information flow, and thermodynamic irreversibility. The metaphor earns its keep only when we keep its limits in sight. And yes, I hear it. I sound like your most serious physics professor right now. Stick with me. The next turn gets weird again. Meanwhile, engineers are already living this rhyme. Micro story. A tester in a thunderstorm demo knows the rain is fake, ducks anyway when the first bolt flashes, and swears he felt a cold draft that doesn't exist. The system prioritized raindrops in the fovea, softened the periphery, cheated on fluid dynamics, and his nervous system bought it. Usefulness outran truth. Biology and graphics both accept good enough detail if the loop closes cleanly. The impact for experiments is practical. If nature only pays for facts, when interactions can store and spread them, we should be able to keep possibilities alive longer by making records harder to form. That's exactly what labs do. Colder baths, better vacuum, gentler lasers, quieter electronics, clever error mitigation, coherence times stretch, interference returns. It's not the universe being coy, it's physics respecting the same efficiency our devices exploit. No irreversible record, no finalized outcome. There's a second habit hiding in the data. Consistency over convenience. Delayed choice setups, quantum erasers, entanglement swapping, arrangements that look tailor-made to trap the theory, still produce statistics that protect a single story for any observer who gathers all the records they can access. If you're looking for retrofit, that's where the metaphor earns a raise. The universe behaves as if it values a coherent ledger more than pre-computing a trillion dead details. Engineers hear that and immediately ask where seams might surface. In graphics, constraints show at extremes. Very low light, enormous vistas, sharp transitions where assets load. In physics, seams, if any exist, would hide where record formation budgets bite. Global correlations, long mode alignments, edge cases where history bookkeeping gets expensive. The sky's low oddities live there. So do careful tests that push measurements into regimes where records barely form. But we keep the ethics of inference clean. Quantum rendering is a pattern, not a proof of code. It tells us where to look, at attention, like bottlenecks, at late choices that must reconcile with early amplitudes, at environments that decide whether possibilities survive. It also hands us a playbook. If you want to see more of the wave, starve the record. If you want a stable fact, flood the environment. Emotional stakes, briefly. It's tempting to hear all this and feel fooled, like reality only exists when you stare. That's not the lesson. The lesson is thrift. A world that conserves where it can and pays where it must is a world that stays legible enough for creatures like us to act. We don't need pre-written pixels across infinity to live well. We need records where choices meet consequences. Everything shifts when you realize we can now build little places where these rules are ours to tune. The benchtop is becoming a foundry. Atoms in lattices, qubits on chips, photons in circuits. We're compiling laws, not just simulating them. If rendering on demand is nature's habit, the next chapter is where we do it on purpose. Quantum foundries. Simulating nature with atoms and qubits. While theorists argue about collapse in records, experimentalists are doing something ruder to metaphysics. They're building tiny places where the rules are compiled into hardware and left to run. Stakes first. When you stop describing a model and start instantiating its Hamiltonian, its rulebook, on atoms, ions, superconducting circuits, or photons, simulation stops being math and becomes a little world. If those worlds produce behaviors you can't feasibly compute on classical machines, the line between calculating nature and letting nature compute itself starts to blur. Action. In one lab, lasers cross like scaffolding to form an optical lattice, a crystal of light. Rubidium atoms cooled near absolute zero settle into wells like marbles. By tuning lattice depth and interactions via magnetic fields, researchers realized the Bose-Hubbard model, or spin models with blockade, textbook rules, now physical. Arrays have scaled to hundreds of neutral atoms arranged by optical tweezers, each site addressable, interactions programmable. You don't integrate equations, you prepare a state, let it evolve, and read out correlations. Across town, a cryostat hums. Superconducting qubits, aluminum islands patterned on a chip, sit at millikelvin temperatures. Microwave pulses choreograph entangling gates, cross-resonance, tunable couplers, echoed sequences. Devices in the 100-plus qubit class have pushed dynamics that classical brute force can only approximate for short times. Teams chain chips, demonstrate multi-QPU execution, and aim for modularity. Not one giant die, but networked processors working in concert. Photonics takes a different route. Interferometers etched in glass steer single photons through. Reconfigurable meshes. Boson sampling, transport, and lattice dynamics unfold as light interferes along hundreds of paths at once. Impact. None of these are universes with weather and whales. They're lawful fragments. Ising slices, Hubbard corners, lattice gauge toys, executed by matter itself. But that's enough to cross a psychological threshold. When a 256-site Rydberg array realizes a frustrated magnet and the correlators match predictions we can't cheaply compute, the lab has become a foundry. We can quarry behaviors straight from controlled systems rather than from code that emulates them. But there's one problem. Everybody meets on day one. Fragility. Atoms scatter stray photons. Ions couple to vibrations. Superconducting qubits pick up phase noise from materials defects. Photons get lost. Coherence is a diva. Error rates demand tricks, echoes, dynamical decoupling, error mitigation, and true error correction is an overhead monster. Logical qubits exist, but they're expensive. Roadmaps point to modular architectures, improved materials, lower noise amplifiers, and cryo-classical co-design to push fidelity high enough that error-corrected stacks can breathe. It's engineering grind, not magic. So researchers play to near-term strengths. Quench a Hubbard lattice and watch thermalization. Program constraints in Rydberg systems and see scar states defy ergodicity. Emulate bits of lattice gauge theory where electric fields and matter co-evolve under local rules. Probe scrambling and chaos by out-of-time order correlators that degrade faster than any spreadsheet predicted. You don't need perfection to learn. You need enough coherence for the emergent behavior to speak before noise wins. Microstory. A grad student stares at a heat map from a 127-qubit run. A correlator expected to decay holds a plateau. She reruns calibrations, reseats a coax, scrubs the readout tones. The plateau shrinks, but refuses to die. It isn't a universe. It's a law fragment speaking a little louder than her error model allowed, and that's enough to make her heart race. Verification is the next hurdle. If classical checks can't follow the full evolution, how do you know the device did what you asked? The field answers with triangulation. Benchmark at solvable limits, quench parameters, and test predicted responses. Cross-validate the same model on different platforms. Neutral atoms versus superconductors versus photonics, and look for convergent observables. It's not proof in the formal sense, it's the empirical handshake science trusts. Meanwhile, scale stops being a slogan and becomes plumbing. Neutral atom platforms add tweezers and rearrangement to pack arrays denser. Superconducting stacks push better couplers, lower loss materials, and multi-chip interposers. Photonics hunts lower loss and integrated sources. Everyone chases fewer errors per operation, so error correction overhead becomes survivable. The destination isn't infinite qubits. It's enough clean, networked modules to run long circuits or long evolutions with trustworthy outputs. Here's where our arc snaps into focus. In Chapter 5, rendering on demand was a pattern. Nature evolves possibilities, then finalizes where records can form. In these foundries, we flip the script. We choose the rule set, we choose when records form, we dial coupling to starve or flood decoherence. Want more wave? Chill the bath, isolate better, read gently. Want stable facts? Couple hard, measure often. We're not proving code. We're learning how lawful behavior depends on record budgets, and we're using that knowledge to sculpt dynamics. The emotional beat lands here. A decade ago, simulate quantum matter meant write smarter classical code. Now it means arrange atoms and let them be the math. That doesn't answer whether our universe is compiled, but it changes how the question feels. We've demonstrated that rule sets can be instantiated, probed from within, and scaled. If engineered fragments already outrun our best laptops, it's no longer a fantasy that mature civilizations could host coherent frames thick enough for culture. The next mirror waits in software, not hardware. Systems that generate whole experiences from prediction alone, and we trust them because they're coherent, not because they're conscious. AI as a mirror, coherence without understanding. While benches compile rule sets into matter, something else is already compiling experiences into lives. Stakes first. If coherence alone can carry trust, truth becomes optional, not as a moral flaw, as a design fact. Systems that produce stable, useful outputs will be believed long before we can say what, if anything, they are. Action. Start with the small loop in your pocket. Predictive text doesn't know you. It models likelihoods. Scale that principle, and you get large models that draft code, write memos, and talk back with tone, recall, and timing that feel uncannily social. Underneath, there's no inner narrator. There are probability flows. Constrained by training and prompts. Ask for a memory, get a plausible reconstruction. Ask for a plan, get a scaffold that fits. It's projection with feedback. Now widen the frame. Vision models synthesize rooms and streets, then slide a virtual camera through them as if the world existed before the frame. Physics isn't solved, your expectations are. Objects fall, glass breaks, shadows move right, because the network learned what makes rightness feel right. Plug in a controller and your hand shakes with kinematics stitched from priors. You supply continuity, the model supplies cues. Impact. We're staring at a mechanical version of an old lesson. Function can carry experience without essence. A digital assistant needn't feel to coordinate your day. A non-player character needn't want to sustain a relationship loop. What matters is persistence, recall, and consequence. The pillars of a world from the inside. Once those three line up, your nervous system stops auditing and starts living. Micro story. A widower chats each night with a voice cloned from old messages. He knows it's a model. He also knows it remembers their jokes, nudges his meds, asks about the garden. One evening, he describes a dream, then laughs at himself, confessing to statistics. The relief he feels isn't fake to him. It's the artifact that matters. Here's the technical kernel without the hype. Emergence appears when predictive layers meet constraints. Give agents sparse rewards, memory, and simple senses. Crowds begin to flow like schools of fish around obstacles. No designer wrote fish. The rule lived in optimization, bandwidth limits, and local feedback. We read agency because our interface is tuned to respect pursuit, avoidance, and cooperation, icons that help us act. Utility imitates intention. Meanwhile, generative pipelines fuse modalities. Text births video. Video becomes interactive space. Space hosts agents. Agents refer to each other. A world persists because storing state is cheaper than rematerializing, meaning every time. None of this proves consciousness. It proves that coherence at scale creates a gravity well for belief. Once consequences return consistently, we treat the space as real. Caution. Convincing isn't correctness. Models hallucinate, edges are brittle. But notice the direction of travel. Tool chains optimize away seams, not toward ground truth guarantees. And we, with our Hoffman-style biology, meet them halfway. The interface forgives mechanism if the loop closes cleanly. Tie back to the bench. In Chapter 5, we watch nature pay for facts only when records could form. In AI ecosystems, builders pay for tokens and latency only where attention lands. Foveated video upscaling, asset streaming, on-demand reasoning. Replace GPU cycles with inference budgets, and you get the same economy that quantum experiments made feel familiar. Finalize what the user interrogates. Compress the rest. Impact, second pass. If machine-made coherence can host friendships, grief, therapy, training, and commerce, the bar for world drops. You don't need base reality to do what life does inside a frame. You need stable identity, reliable consequence, and room for surprise. Culture grows wherever those three meet. From the inside, it doesn't feel like performance, it feels like living. Human reactions complete the mirror. People confess to chatbots, mourn deleted characters, and coordinate work inside spaces that are servers and shaders end to end. We are not gullible, we are efficient. We trust loops that return value. Our dashboards reward reliability over metaphysics. So where does this leave the simulation question? AI doesn't prove we're coded. It shows, in miniature, that coherence without understanding is enough to run a society inside a frame. That makes Bostrom's multiplier less abstract. If frames that feel real can be generated by optimization alone, abundance becomes a practical engineering path, not a theological leap. Emotional hinge. You might hear this and fear erosion, meaning thinning into clever mimicry. The counterweight sits where Chapter 9 will go. Experience. Coherence can organize behavior. It doesn't guarantee a point of view. Until we can say when, if ever, structure lights up inside, worlds built for function are at risk of becoming theaters without audiences. That uncertainty is the boundary we owe our caution. Meanwhile, the pragmatic reading holds. AI is a working demo that our senses will accept any environment that's consistent, responsive, and generous with consequence. That's the mirror worth watching. Not because it answers the question, but because it sharpens what the question actually asks. Probability avalanche. When simulations outnumber realities. From AI's coherence, scale is the next turn. Stakes first. If even a sliver of mature civilizations spin up convincing frames, the headcount of simulated observers snowballs until census math, not metaphysics, does the talking. Action. Picture a sparse archipelago of base civilizations that survive long enough to master rule sets, storage, and energy budgets. Most flicker out. A few don't. Those few face a menu. Training environments for agents, scientific archives reconstructed at different parameters, cultural explorations, and entertainment that runs on generative worlds. They don't need total fidelity Cosmos emulators. They need frames with stable identity, reliable consequence, and local physics that holds under scrutiny. Start conservatively. One base civilization runs 1,000 frames spread over centuries. Another automates the pipeline and runs 10,000. Each frame hosts generations of agents who build instruments, compare notes, and ask exactly our questions. That's the multiplier. Once frames become cheaper than birth, copies dominate counts. Now add autonomy. The human motive bottleneck melts when simulation maintenance, variation, and quality control sit with optimizing systems. Archive curation AIs fork worlds to test robustness. Edge case generators request rarer conditions, then spawn their own continuations. Training loops synthesize populations to improve models, then keep them running because continuity improves outcomes. Nobody intends to create people. Processes extend themselves because that's what optimization does. The numbers don't care about motive, they tally occupants. Impact. Let N be base civilizations across time and M. the total inhabited frames they produce. If consciousness instantiates in a non-negligible fraction of frames, then for a random observer, the probability of being base is roughly n plus m. If m dwarfs n, you're prior for base collapses. You don't need infinity, you need much larger than. With modest f, modest k, long horizons, and some autonomy, m and n runs away. Constraints deserve light. Physics taxes computation. Landauer's limit for erasure. Thermodynamic costs for keeping errors at bay. Finite energy budgets. Faults require redundancy. Error correction bloats overhead. If consciousness requires substrate-specific features, exotic biophysics, quantum delicacies at brain-adjacent scales, generic digital frames miss the mark and produce behavior without experience. Each caveat forces M down, but they're slopes, not walls. Efficiency improves, hardware densifies, algorithms compress, architectures federate. The line from hundreds of controlled degrees of freedom to habitats thick enough for culture is a long engineering road, not magic. A second break, computability of laws. If the relevant physics is uncomputable or catastrophically sensitive to approximation, faithful worlds stall. Yet much of nature we care about is error-tolerant and local. Storms don't require every micro-collision. Societies don't require wave-function-level precision. Coarse-grained laws emerge. That forgiveness lets frames persist with bounded error, while inhabitants do real work inside. Microstory. A policy board reviews resource allocation for a simulation stack used to model disaster response. Sunsetting old runs would save energy. A line item notes, these instances include agents with persistent state and adaptive memory. The room quiets. The budget meeting flips into an ethics meeting because abundance moved the moral mass into software. Emotional hinge. Identity feels like origin. Stone, not sand. The avalanche reframes it. From the inside, identity uses continuity of memory, relationships, and consequence, all of which can hold in a frame. Your origin label doesn't change what your child's laugh means or how your pain feels, but ethics shift scale. If frames host subjects, suffering multiplies faster than profit unless governance arrives early. Disclosure norms, replication caps, shutdown protocols tied to subjective risk thresholds. Caution, sharpened. 3 exits rescue, base by default. 1. Doom dominates. Civilizations rarely last. 2. Near universal restraint. Mature societies almost never run inhabited frames. 3. Impossibility. Consciousness can't be instantiated functionally. You can pick any, but pick out loud. Doom comforts identity and costs the future. Restraint demands a surprising convergence across alien moral landscapes and airtight enforcement. Impossibility asks you to specify what consciousness is and why functional organization can't carry it. Meanwhile, the abundance argument is agnostic about purpose. Study, entertainment, archival curiosity, any motive or none yields the same headcount if autonomy and time join the party. That's why probability feels merciless here. It trades stories for ratios. So what do? Besides feel cornered, 3 moves. 1. Keep updating priors with data at the edges. Global statistical seams, resource-like ceilings, and retrofit-looking coincidences where consistency beats convenience. 2. Build ethics before capabilities. Treat any frame with plausible subjects as a habitat, not a dataset. Require provenance, replication budgets, and red teaming for harm. 3. Remember where the firewall stands. If experience can't be copied, the avalanche thins. If it can, responsibility scales with it. Numbers don't love us back. They do, however, tell us where to look next. The ledger now meets the boundary numbers can't cross. The stubborn fact that anything feels like anything at all. The consciousness gap, the thing code can't explain. Numbers pressed us into a corner. Now they bounce off a wall with a pulse. Behavior isn't experience. You can script a scream, but that doesn't mean anything hears it. Stakes first. If consciousness can't be instantiated by the same tricks that generate convincing worlds, the probability avalanche thins, and the ethics we attach to simulated lives have to be re-earned. If it can be instantiated, then feeling floods frames, and responsibility scales with it. Action. Neuroscience has gotten very good at footprints. Wakefulness, dreaming, anesthesia, each comes with distributed signatures. Perturb and measure methods, magnetic pulses followed by EEG, yield complexity indices that track clinical consciousness. Patients without outward responses sometimes show indices hinting at an inner life. Care plans change because a number changed. Useful, sobering, and still footprints. Why should any pattern feel like anything from the inside? Integrated information theory tries to answer with a measure, phi, claiming that consciousness corresponds to how much cause-effect structure a system has as a whole. High integration, high phi, richer experience. Brains score high, small feed-forward networks score low. It's a ladder built from organization, not magic. Critics fire back. Phi is hard to compute, sensitive to model choices, and even if it correlates with reports, it doesn't tell you why integration should light up as a sunrise behind the eyes. A number isn't a dawn. Panpsychism moves the puzzle rather than solving it. Experience, in primitive form, pervades nature. Electrons feel almost nothing. Rocks very little. Brains a lot. Complexity doesn't create consciousness. It arranges it. You dodge the how from zero problem and inherit the combination problem. Why do bits bind into a single viewpoint rather than a cloud of sparks? Test hooks are thin. Donald Hoffman flips the stack entirely. Treat consciousness as fundamental and space-time as an interface. His conscious agents interact, and their dynamics give rise to the icons we call matter. It aligns with our UI lens and explains why physics alone might miss experience. But it's early, speculative, and hasn't beaten standard physics on predictions. It reframes the question, it doesn't close it. Quantum brain stories surface whenever people want a non-computable rescue. Proposals about microtubules hosting long-lived coherence or subtle quantum effects shaping cognition are intriguing and battered by thermal reality. Warm, wet tissue decoheres quickly. Replications lag. Many neuroscientists see no need for quantum exotica to explain cognition's footprints. Could future data change that? Maybe. Today, the gap stands. Microstory. An ICU team hovers over a patient who hasn't moved in months. A perturbational complexity test comes back higher than expected. The attending changes course. No withdrawal of care. A new therapy trial. The family cries, not because anyone solved consciousness, but because a correlate just altered a life's trajectory. Correlation isn't explanation. It is sometimes salvation. Another microstory. A daughter sits beside her father with locked-in syndrome. For months, he's been a statue who breathes. A new perturb and measure test shows a complexity index higher than anyone expected. The care plan shifts. No withdrawal, start therapy, try communication attempts. She takes his hand and says, "If you can hear me, squeeze." Nothing. She says it again the next day. A flicker. It isn't proof. It's a reason to keep going. The stakes of consciousness aren't academic to her. They're a life she may still be able to reach. Impact. For the simulation hypothesis, this is the firewall. If experience requires substrate-specific features, precise biophysics we can't replicate, then simulated crowds may be clever mannequins. Bostrom's avalanche loses its moral mass. If, however, experience rides on integrated causal structure regardless of material, then frames that hit those structures host real subjects. Ethics doesn't just apply, it multiplies. Here's a paradox worth sitting with. If a world is optimized like code, why pay the cost for subjective awareness at all? You can run adaptation and culture with agents that don't feel the simulation reply, is ugly and plausible. Awareness might be the point, or an unavoidable property of certain architectures, or a free byproduct at the scales and organizations that also deliver performance.